Okay, so today's demonstration is to show you a linker that we've written for Camel99 Forth that will let you write assembly language programs. We'll just load up some tools here to start with. This linker will let you write your programs in conventional TI assembler, generate the object files, and then with the linker you'll be able to link those files into a memory buffer in Camel99 Forth space and call both the programs, subroutines, and access data in those programs from the Forth command line. So this would be best useful for testing purposes. So we'll compile the linker, and it pulls in a number of little library files to support itself, and then we'll show you how that works. Now the other additional feature of this is you can write up the accessing this data in a link script. So you could have a number of object code files. You can write up a script that links all those files and then use the Forth command include and just interpret that link script and do all this. But I'm going to type it in manually so you can see how it's done. The command that is used immediately before you start linking is new period, which clears all the low RAM. You have 8K in the TI-99 to put your code into. You can run a label in your program, which you can't get back from unless your program actually returns to Forth in the appropriate way, branching through R10. You can call subroutines in your code and return back to Forth. And you can branch and link Workspace pointer, BLWP, to subprograms in your assembly language code and return back to Forth as well. If you want to, you can declare the defs in your assembly language program, which the defs are the references to things that will be accessible externally to other programs. And they exist as text labels in the object code. So that dovetails nicely with Forth. So you can redeclare in the Forth workspace these definitions as external, and the commands extern, xsub, xprog, and xdata let you do that. You probably wouldn't want to use that very frequently, since I see this mostly as a test platform for interactively testing assembly language programs. So let's do a little linking. We'll get ourselves a new page here, and we will link disk4.thing, what's it called? Thing1. Thing1, where are you, Thing1? There we go. So we link that, and it's a short little program. It has externally provided the labels ThinkL, Think, and Thing1. Now Thing1, we'll just take a look at it here. Whoops, I also have to make sure that Forth is searching the defs workspace. And so now we can see there is the defs workspace words. Now Thing1 returns the address of 2000. Thing1, if we look at the contents with the Forth question mark, returns a 20 hex, which is the space character, ASCII space character. And that's what it's initialized to in the program. So we're already interactively accessing data from the programs. And I should add at this stage that these programs were provided courtesy of Farmer Potato from the Atari Age forum, TI-99 forum. So thanks very much, Farmer Potato. So let's link another program. Link disk4.thing1 thwack. And now we can see that we have a new label, loop. We have thwack, we have thinkl, we have think, and we have thing1. Now thing1 we know is just a piece of data. thinkl I think is a subroutine. Think is an actual subprogram with its own workspace. And thwack is a subprogram with its own workspace. And loop is an endless loop that calls think and then calls thwack. And if you enter loop, you can never return. It doesn't have any way to break it. But let's just do something like, I'm going to make a new page here. Take a look at, oh, those are not the words we want. We want to go, what order are we in? Okay, we want to see the defs. We want to look at defs words. There we go. So let's see what happens if we go think BLWP. Not much. But let's take a look at thing1, and we can see that it was incremented. Let's try that again. BLWP. So we're running the program think, and we look at thing1, and it's incremented again. Cool. Let's run the program. Just for clarity, if we look at what is 22, it's a quote character. So let's run the program thwack, which we need to use BLWP. And we can see, look at that, quote characters appeared on the screen. Okay. Now, so we know what think does, we know what BLWP does, and we know that thing1 is a piece of data. What else could we do? Well, we can write some Forth code and actually use this external code that was written in TI assembly language. And there's a little Forth loop that calls think, then it calls thwack, then it checks if the break key was pressed with the command Q terminal, and it does that, and it loops until that break key is hit. So let's run test, and we can see it's doing what the good farmer designed it to do. Put a bunch of characters on the screen in a fast block write. And if we hit the break key, we're back to Forth. Now there's one other thing we could do. We looked at the loop word, and I mentioned that the loop word is an endless loop. You can't get out of it. The way to get into it is to use the branch instruction, and that has been named run in this linker. So we can go loop run, and this program will enter and never end. And that's the end of our demo. That's the Camel99 Forth Linker.